Hi there everyone. So before we get into the feedback on the question at the end of last lesson, I'd just like to show you the Sudoku completed solution. So if you had a go at that and you'd like to check out where you got stuck and you'd like to see where your mistakes were, pause the video and have a look at that now. Now, quite a few of you made some lovely notes which you uploaded to me from last lesson, so that's great. I said that that's your lesson submitted as such, but I really did ask you to have a go at question 9, and there was only one of you who did that, and what made me think was how well many of you could have done if you'd had a go, because the person who did have a go had a brilliant go and got 4 out of 5 marks for it. It was just one little area where it went a little bit wrong, so just do have a go at it. If it goes totally wrong, there's no shame in that. You'll learn more from me going through it if you've had that little attempt first of all. Now, this question is saying that the farmer's going to sell the field for £3 per square metre. So we need to know the area of the field in square metres, and then we can multiply that by 3. Now, this is a compound shape. It's got a rectangle and a right angled triangle. So the easy part first, if I call this A and this B, A is going to be length times width, 100 times 75, which is nice and easy. That's 7,500. Now B, we need the base, which is that bit, which is going to be 160. Take 75, because that bit there is 75, and if we take 75 away, that leaves us with 85 meters for the base, and the base is the length times the width, all divided by 2, remember. So the width, or the perpendicular height, I should have called that, shouldn't I? So if this is 30 and the whole length is 100 take 30 leaves us 70 meters from there to there. So it's 85 times 70 over 2. So you can do that with long multiplication, or I don't mind you practicing using your calculators on this. If you've got time, practice your long multiplication and then check it with the calculator is often a good thing to do, and that should give us 2,975. I think with these numbers it probably would be the non-calculator paper, to be honest. Now, at this point, a person multiplied this number here by 3, but we want the area of both bits added together first of all. So the first thing to do is get the 7,500, 2,975 and add those together. So that gives us a 5, 7, 9 add 5 is 14. 7 add 2 add 1 is 10. So that gives us 10,475 square meters. But every square meter is worth £3. So we need to multiply that by 3. So I'm just going to do that here. 3 5s are 15, carry the 10. 3 7s are 21, add 1 is 22. 3 4s are 12, add 2 is 14, 3 zeros are 0, add 1 is 1, and 3 1s are 3. So that gives us our final answer of £31,425. Okay, and I think that's a very doable 5 marks. In the foundation paper, you'll get some nastier questions like that. You want to look for these questions and really give them a good go. Right, so our next thing that we're going to be looking at is surface area. Now, area is a 2-dimensional measurement, but surface area is the amount of 2-dimensional space that covers a 3D object. So the simplest kind of thing that you might have would be a cube. So if you had a cube looking like that, and it was 1 centimeter, a 1 centimeter cube, this would be 1 centimeter squared, wouldn't it, just for that area. But if you were to maybe pause the video and see if you can draw the net of the cube for me. Right, so you could do, there are many different nets that you can draw, but the most common one is a cross. Now that's got 5 faces, so that's 6. So we would have 1, 1, 1, 1, 1, 1, which adds up to 6 times the 1. We've got 6 of those, is 6 centimeters squared. What if we had another cube? By the way, if you're not too comfortable at drawing a cube, just start by sketching a square, and then if you put one dot about halfway up but going back there, and then draw another line the same height, and then connect that up there, and then go across there again. There you go, you've got your cube, just about. If I say it's 2 centimeters in each direction, pause the video and see if you can work out the surface area of that cube. And for one area, for one face, you should have 4 centimeters squared, because 2 squared is 4. But then you're going to have 6 of those faces, and 6 times 4 is 24 centimeters squared. At the same time, let's bring in the idea of volume. What is the volume of this cube? Because this is a weird thing. The volume of this cube is 1 centimeter by 1 centimeter by 1 centimeter. And when we say 1 by 1 by 1, we can work out how many there would be in by timesing 1 by 1 by 1. Well, it's fairly obvious when it's 1. You've just got 1 cubic centimeter, because it's got 1 centimeter in each direction. And this is what we call cube numbers come from. The volume of this 2 centimeter cube is going to be 2 times 2 times 2, length times breadth times width, because it's got 3 dimensions. And that would be 2 times 2 is 4. In fact, I'm going to underline that to do it in 2 bits to make sure we get this right. 4 times 2 is 8 centimeters cubed. Right, what I would like you to do is see if you can sketch and do 3 by 3 by 3, and I want the surface area and I want the volume. I would like you to have a go at doing 4 by 4 by 4, surface area and volume, if it's a 4 centimeter cube. Let's keep going and let's do a 5. I'm just going to draw them as if they're the same size, but you get the idea. Surface area, volume. You'll need to do a little bit of calculating, but not that much. Then we'll go to, yeah, okay, give 6 a go. And something interesting I'm hoping you'll notice will have happened. Now we've just got room to put one more on, so we'll jump to a nice easy one. I'd like you to have a go at doing all of this without a calculator. And this time we're going to go for 10 centimeter cube. So imagine I put centimeters on all of this. And I've done that now. Right, pause the video and have a go at doing that. Right, so our surface area here, you should have 3 times 3, 3 squared equals 9 centimeters squared just for one face. So it's going to be 6 faces of 9, and 6 times 9 is 54 centimeters squared. The volume is going to be 6 times 6 times 6. 6 times 6 is 36, times that by 6, well 6 30s are 180, plus another 6 6s are 36 on top of that, should give you 216 centimeters cubed. I'll put a little gap in between there. Right, the surface area this time, 4 times 4 gives you 16 centimeters squared for one face, but you've got 6 faces, so it'll be 6 times 16. 6 tens are 60 plus 36 gets you 96 centimeters squared. Volume on this one is going to be 4 times 4 times 4. 4 times 4 is 16, times that by 4 gets you 64 centimeters cubed. I wonder if you've spotted my mistake that I made before. This is silly, isn't it? This 6 times 6 times 6 one is actually the volume for this one here, isn't it? So I'm going to put my 3 times 3 times 3 working over here, which is what I should have done for that. 3 3s are 9 times 3 is 27 centimeters cubed. So I'm going to swap those two over. And there's a reason for me talking about this at this point. You notice this surface area is getting bigger and bigger, but this surface area number is bigger, 54, than 27, but it's exactly double it actually. Whereas this one is still bigger than 64, but not by as much as double. And over here, the volume number was 3 times smaller than the surface area number. So an interesting thing is happening. What do we get on the next one? 5 5s are 25 centimeters squared. This whole surface area will be 6 times 25, which is 150 square centimeters. The volume is going to be 5 times 5 times 5. Now 5 5s are 25. 25 times 4 is 100, so 25 times 5 is 125 centimeters cubed, and that number's now getting closer, isn't it, to the surface area number. When we get to the surface area of the 6 centimeter cube, this is all because it's got 6 faces. We get something very interesting. 6 6s are 36 centimeters squared, so the surface area is going to be 6 times 36. Well, that's the same calculation that we did over here. So we get 216 centimeters squared, which is the same number as the volume for the 6. So if that number's now caught up and is the same, what's going to happen when we do it for 10? Well, 10 squared is 100 centimeters squared, so each face of the cube is going to be 100. So the surface area is going to be 6 times 100, which is 600 centimeters squared, and the volume is going to be 10 times 10 times 10. Well, 10 times 10, as I'm sure you know, is 100. 100 times 10 is 1,000. So now the size of the volume has got bigger, and that's what happens with volume. As soon as you get to, when you've got small numbers for your dimensions, the area, the surface area, will be bigger than the volume. But once your numbers get big, then very quickly the volume gets a lot larger, which is one reason why these little numbers here are called powers. Right, now for the rest of today's lesson, we're going to be looking at the surface area of cuboids. Now they come up quite a lot. So a cuboid, like a stretched cube, isn't it? It's made up of rectangles. It's a rectangular prism is another word for it. So if I put a rectangle there, then I make another distance going back. There is my little sketch of a cuboid. Now what sort of distances might we be talking here? Let's keep it quite simple. Let's say that's 2 centimeters. If that was 2, then that looks like about 5 centimeters there, and the depth there could be about 4 centimeters, couldn't it? Now what's that going to be like as a net? Now if you've got some squared paper, that might be a good idea. But if not, I challenge you to have a go and do it the way that I'm doing it, because sometimes just thinking about this stuff is a good thing to do as well. I want us to think about the fact that this is the front and then this is the left side, and this is the top. And I would like you to have a go now at pausing the video and sketching the net of that cuboid. So I'm going to start with the front. So there's my 5x2, and that's my front. And the area of that front is going to be 5 times 2 equals 10, isn't it? Now, attached here to the top, at the top, we've got the top. So this will be nearly as long as that distance there, but not quite. So this is the top, and the area of that top is going to be the distance back that it is, which is 4, by the length that is 5. So we've got 4 times 5, which is 20 centimeters squared. So we've got a 20 there and a 10 there. Now, what happens if I go below here? The bit underneath would be the bottom. Now the bottom, if you imagine this is just a cardboard box that we're folding out, the bottom is going to be identical to the top. So that's also going to be 4 times 5 equals 20. How about the left hand side? That's going to come back the same distance as that, isn't it? So there's the left. I'm just going to put an L there. What's the area of the left going to be? Well, it's 2 high and it's 4 wide. So 4 times 2 equals 8. Let's do the right hand side. The right hand side is going to be over here. If I dot that in behind there, it's going to be exactly the same size as that bit there. So the right hand side, just make my little sketch there, is also going to be 4 times 2 equals 8. Now how many sides have I got? 1, 2, 3. So what have I missed out? I've got the front, I haven't got the back. If I dot that in there, the back, just to make it really clear, the back is going to be sort of going across there like that, isn't it? And the back is going to be the same size as the front. And I could draw it at the top of the top or the bottom of the bottom. I'm going to stick it at the top of the top, I think. And that's also going to be 2 wide there, isn't it? So the back, and the back is also going to be 5 times 2 because it's the same size as the front. So what's the total surface area? I've got the back, I've got the top, I've got the front, I've got the left, I've got the right, I've got the bottom. That is the most economical thing to do. By economical I mean the thing which is going to cost me the least amount of effort to write all of those out. Or do you spot something? I'm hoping that you may well have spotted that we've got 2 that are the same there, of 10. We've got 2 that are the same there as the 20s. And we've also got the 2 8s at the side. So a different thing I could do, I mean, I could add these up and get 8 add 8 is 16. 1 add 2 is 3, add 1 is 4, 5, 6, 76 centimeters squared as my final answer, and that's fine. Or I could say, I know I've got a 10, an 8 and a 20. I'm just going to add those up to get me 38, and then think I'm going to have 2 of those. So I'm going to times it by 2, which I could just do by multiplying, or I could just do by adding another 38. 8 add 8 is 16, 3 add 3 add 1 is 76. And I think that's a bit simpler, and it may help us out with doing a few more, which we're going to have a quick go at now. And what I realise is we've pretty much come to the end of our 20 minutes, so I think I'm going to stop there, and tomorrow we're going to be doing surface area of all sorts of prisms, but we'll start off with a cuboid, and I'd like you to see if you can have a go when you do it at thinking, I'm going to have 3 different sides and I'm going to multiply the different lengths by what they find out the 3 different sizes that I've got, and when I've got my 3 different rectangles, add them together and double it. Or if you want to do it the long way, that's fine too. Okay folks, cheerio.